Welcome to Brain Vision.
So in this question, we have a stretched string, and this stretched string has a match per unit length, 5 grams per centimeter. Tension of 10.0, a sinusoidal one travels on it, and that has an amplitude of ym equals 0.10 millimeter. We have a frequency of 100 hertz, and then traveling in the negative of s. So if we write out the formula, we will know that it was sine of kx. This change is plus or minus omega t, but we know it's in the negative direction, so it has to be plus t. So let's first look at part A. What is T12? We're told it's 0.12 millimeter. What is B is K. In order to find K, we need to find out what is K is 2 pi over lambda. We need to find out what lambda is. In order to find out lambda, we need to figure out, well, is V over frequency. Figure out what V is. When we find V, how to find the travel? Okay, it's a stretch, so we know how to do that if we have the mass per unit length and the tension. So we need to actually first work out how this works and figure out what K is. Let's do that right now. So V is the tension over the units. So that's 0.5. Why not just combine the formulas? So I think I'll write them together. I have V equals square root of tension over unit mass. So I plug this into the previous equation. So lambda equals 1 over f of this. Then I plug this into the previous equation. I find out this expression of K equals 2 pi f of square root mu over tau. Okay, and now I can plug in the numbers. It equals 2 pi times 100 hertz times of 0.5 kilogram per meter over 10 Newton, which is 141 meter. So that is part B. We also have part C, just to find angular frequency. We know the frequency 100 hertz, so angular frequency is just 2 pi f. So it's 2 pi times 100 hertz, which is 628 radians per second. Finally, asked to say what is the side in front of omega, because it's traveling in the negative x direction, to have a plus sign in omega.